Hey everyone, and welcome to the November 2023 edition of the Azure Functions livestream Community Stand-Up. I'm Thiago Almeida, and today I'm joined by Ramya and Radhika. They've been very busy bringing the Dapr extension for Azure Functions, among other projects for Azure Functions as well. And we've had quite a lot of updates in the past month that we want to share with you. So this session will have two parts. One will be a deep dive into the Dapr extension for functions running on Azure Container Apps and how to build microservices with those two combined, that Ramya and Radhika will give us a great overview of. And then later, I'm also going to give some extra updates that we had from .NET Conf last week and also Microsoft Ignite. With that, I'll pass it on to Ramya to tell us more about the Dapr extension for Azure Functions. Welcome, Ramya.
Sure. Hey, thanks, Thiago. Thanks for having us on the show. We are really excited to talk about the Dapr extension for Azure Functions that we've recently launched. It's in preview now. And we've also done some work on functions on Container Apps side. It's a new hosting environment, which I'm about to talk about, to kind of enable that seamless integration between Dapr extensions and function apps on ACA. So yeah, I'm Ramya Urganti. I'm currently working as a PM with Azure Functions team. My focus areas are enabling functions on Kubernetes-based environments, and I also focus on a few event streaming triggers like Kafka, Event Hub, and RabbitMQ. Apart from this, we also work on an OSS component called KEDA, which helps with scaling of pods dynamically based on events. So yeah, I'm super excited to talk about the extension, its capabilities. I'm also going to talk about the use case scenarios, and we have Radhika, who's the engineering lead for Azure Dapr extension. She's going to present a cool demo, and you're going to see Azure Functions and Dapr extension in action. So we've recently launched Azure Functions on Azure Container Apps in public preview. And this is to kind of enable event-driven serverless Azure Functions for microservices. So it's a new hosting option that will enable developers to quickly build event-driven cloud-native function apps with the flexibility to run functions along with other microservices, APIs, websites, workflows, or any container-hosted programs. So it supports functions integrated programming model. So users could use triggers and bindings. You could pick the language of your choice and integrate these function apps with other APIs. And these APIs could be of mixed programming languages, right? You could have your function running in .NET, and you could have your other APIs and websites, let's say in JavaScript, and your APIs written in Python. So all of these different types of apps can be run in a single container environment and can be interacted or integrated together. So the promise of true cloud-native experience is about managing with DevOps processes and tools. And this is already offered by Azure Functions. So you can use the same tooling and management experience that you're already familiar with in Azure Functions. And you can deploy the code to cloud using both GitHub Actions and Azure DevOps pipelines in this new hosting environment as well. And you can integrate with multiple app types. For example, you could have a web app, you could have a function and an event source, and all of them could be hosted on containers. And you'll be able to integrate them, build and deploy all of them together using the infrastructure as a code templates like ARM or Bicep. And apart from this, you could leverage technologies like Dapr to weave in these apps together. So this capability of having the Dapr component at the platform level, where you need not explicitly install anything, enables you to build those resilient and secure system. You could leverage all of the proven best practices that are available for distributed application programming development offered by Dapr. And we're going to talk more about this in this segment. So do note that you don't have to worry about managing the underlying infrastructure like configuring network or observability. So because these settings are shared with other apps in this container app environment as such. And finally, function apps can auto scale. They can scale all the way to zero and become inactive, or they can scale to dozens of containers under high load, which means if there's no traffic for a certain time, so the pods are scaled all the way to zero. And when they are scaled to zero, you don't have to pay for that. So you only get to pay when the containers are actively processing requests using the consumption plan support that's there in this hosting environment. Uh, so there's no extra charge for Azure Functions on container apps as such. So we are not charging extra. So the function executions are built according to the container apps. So you have the option to set min replica to 1 and pay the idle pricing when the replica is inactive as well. So certain scenarios where you absolutely have high cold start requirements, you could set these min replicas to 1, and as the events happen, you essentially don't see the container being started from zero. It's already there in an inactive mode, in an idle mode, and it immediately brings up the process and processes the events as such. And then, like, going back to the scaling, right? So scaling typically happens due to the load or messages in event sources like queues or event hubs or databases. And KEDA is that open source tech that makes that happen. So with the seamless integration with KEDA, you need not explicitly configure the scaled objects like you do in an AKS cluster or other Kubernetes environment. So the scaling configuration is auto configured for you in functions on ACA hosting. So as you can see, we're trying to get you quickly get started in deploying and running your function apps. So Azure Functions provides various plans and options to deploy functions, and as per your business need, you could leverage the SKUs that are available. So if you have requirements to deploy functions as containers and you want to run functions in a microservices environment, then you could go with the functions on Azure Container Apps. So that's the option. So moving on to the next, right? So we're talking about Dapr extension, right? So Dapr extension, like I mentioned, so we've built a seamless integration specifically in this queue, the Azure Functions on Container Apps. So in order to enable users to build functions to react to events from Dapr specifically or external systems, and helps integrate between functions. So this Dapr based function app and other Dapr APIs or external systems. So all these integrations can happen between functions and other microservices or APIs or container hosted services in this Azure Container Apps environment. So all this is possible using the Dapr extension capabilities such as service discoverability, PubSub, and bindings. So together with functions programming model, you can write minimal code to use Dapr, uh, or to use all of the Dapr capabilities, bindings, and trigger attributes, right? So Dapr extension supports input and output bindings. So the function app could receive data from Dapr, such as state value or input payload from external systems using the input bindings. And then the function apps can send data to Dapr or external system using the output bindings. Right. So here is an example of the workflow of how a function app enabled with Dapr is sending data to a PostgreSQL database. And this is essentially running in a Docker container. Right. So Dapr Bindings has a long list of state stores that it supports at various levels. So as per your need, you can actually pick from one of the state store. As per your application requirements, you could use them and configure them as a state store and build your function app. So moving on to the next slide, I'm going to talk about the service invoke trigger, right? So Dapr extension supports triggers such as service invoke, right? So here a function app or a web app or API can invoke a function app enabled with Dapr using the service invoke trigger. So as you can see, the seamless communication between these different microservices or between two functions, right? So here is an example where a HTTP-based function app is invoking another function app using the secure MTLS channel, and this is possible using the Dapr extension service invoke trigger as such. So as you can see, both the function apps are enabled with Dapr. It has a sidecar, and between these two function apps, a secure channel has been established, and the invoke has been happening as per the events that happen. So, and also do note that the Dapr enable service invoke trigger app is invoked using an app ID. So you need not specifically provide a long URL to kind of invoke your uh, function app enabled with Dapr service invoke as such. So it's pretty abstracted, and and we made it like it's already supported in a Dapr SDK APIs as such, but that's been implemented or applied to a function app that is enabled with Dapr as well. And all this is possible using the app ID. Right. So moving on to the next slide. So as you can see, the Dapr extension with functions can also be used to subscribe to events produced by various event sources. So it makes it easier to implement this pops up patterns and also react to events. So producers send messages to queues and topics, and function apps enabled with Dapr extension can be triggered to consume these messages. So in this case, right, so the function app with Dapr extension can be used in the context of a producer or a consumer. And we've also heard from customers, right? So some of our customers who've mentioned that they have restricted access to Azure from their laptops or workstations, for example, right? So it's a chore to even connect to a service bus with a Dapr extension function app as such, using the Dapr topic capability. So in that case scenarios, so what they could do is they can use the PubSub component they like locally and do the local development and testing, and they could deploy the same app to Azure in a Azure functions using the Container Apps environment, and configure the service bus as a PubSub component. So this component does not involve any changing of code as such. So you only configure the component, provide the service bus connection settings there, and the Dapr extension enable function app would identify this Dapr component using the concept of app ID, and and the same code that the customer developed locally can be used on Azure as well. And so also having the Dapr topic binding by proxy opens up for support for other messaging components. So again, Dapr supports a whole list of PubSub components. And so I've pasted few which are available from Microsoft Azure as such, right? Like the event hubs and service bus queue or service bus topic, or from the OSS side, you have Apache Kafka, RabbitMQ, and so on and so forth. So you're free to kind of choose from the list of PubSub messaging services that Dapr supports. So moving on to the next slide, so I'm going to talk about observability, right? So it's a nice addition to the service invocation and PubSub API. So you would love to look at like how function apps are getting invoked, what are the requests executed per second, how is the traffic. You want to look at the logs, right? So Dapr uses this open telemetry collector, which is automatically deployed and configured in an ACA environment. So this component is able to push the end-to-end traces, right? Like all of the apps that are enabled with Dapr. So all of these logging and tracing is being pushed to the App Insights instance, and once your App Insights instance is created and hydrated with all these traces, you could visualize them in the visualization tool that comes with App Insights. So that's about observability. So moving on, I really want to touch upon functions programming model because it's awesome, the abstraction that you get. Whether you're writing functions in Python v2 or Node 4, there are several developments that are happening. So all that is possible are applied to a function app enabled with Dapr extension as well. Right. So, for example, in such, like, let's say there's a case where there are triggers and bindings. So these can be declared as decorators. Which would help with eliminating the need for functions on JSON config file. And there's this in-editor support, which helps you to easily to reference to documentation. You get all that simplified folder structure, where there'll be fewer files within the function application. So all the goodness of Azure Functions programming model is being applied to the function app using the Dapr extension as well. So moving on. So with that, I hope this gave a good sense of Dapr extension. So it's time to see things in action. So Radhika, who's the engineering lead for the Dapr extension and the Dapr OSS components, will now take us through the demo.
Hi, Ramya. While Radhika shares her screen and unmutes, there was one question that came through from Johnny. Do we have plans for Azure Functions to work with the Microsoft Orleans as well? I know that we've worked in the past on some integrations with Orleans, but I'm not sure if you know of any functions on container apps with Orleans together.
Yeah, I guess we'll have to look into this. Johnny, if you could give more details around this component of Orleans and what is the use case of function app in this scenario would help. Yeah.
Okay, cool. We'll look into it and get back to Johnny. Hey, Radhika, are you ready?
Yeah,
Okay, so I'll let you share your screen and add it to the live stream.
sure. So, Ramya, can you go to the next screen where we have an architecture diagram? Yeah.
Yeah, that's right. So before the demo, I think I would like to give a quick view of the workflow of what Radhika is about to show.
Yeah, sure. So thank you, Ramya. Thank you, Tiago. As Ramya explained that Dapr with functions works very much in the context of functions programming model. So where all Dapr capabilities are driven in the form of bindings and triggers, similar to any other additional integrations that we use with the functions, right? So Dapr also runs in the same way. So I'm going to quickly show a quick demo on the use case where I have a function app, a public facing function app running, which will be triggering which will be initiating a call via Dapr invoking a backend API, which is again another function app running. And it creates a new order. And then using Dapr again, it will go and save the state of the order that gets created in the Redis state store. And then we also see that, as Ramya explained previously, there is a request which is goes through uh, these two Dapr sidecars running, and then we have these within Dapr the inbuilt observability, which will intercept the traffic between these two Dapr sidecars and then publish the traces to App Insights. So we'll see that. With that, I will get on to the demo. I will share my screen. While I bring up my screen, as you all know that most of the functions users who familiar with the local function development, at the same time you can try out locally, and then you can push your code to cloud, right? So similar way, using as Dapr has its self-hosted mode where it running it locally, and then functions running locally with your function host. We will try out that scenario locally, how it looks like. And then we switch to Azure, where I have a function hosted on functions on ACA with Dapr configured. And then we will see how the service invocation call happens over there. Okay. All right. Can you see my screen? Okay. As it was explained earlier, we will be running Dapr in same as a functions programming model. Either you are using the Python V1 model or Python V2 model, whatever the style underlying programming model supports on functions. So Dapr will be initiated in the same language model. So I have a sample here where I'm running a Python v2 Azure function. And then I have a backend API, which is a create new order. It's a Python file. And then if you see here, the Dapr service invocation trigger, which we can initiate directly as a decorator at create new order decorator. This is the function which was declared, and then I'm calling create new order with this trigger. And then for this new order, then we can then we like I will demonstrate that. And if you look at the a quick difference between V1 programming and V2 programming, as explained earlier. If you look at create new order in V1 programming model, you have function.json, which you will be declaring what sort of triggers you will be using in your function, and then you will have the actual function code, which so you have to declare it, write the code, and maintain two different files and all that. So with V2, where you define everything in one single file and you can run from it there. Right. So I'm going to start Dapr. I already have a function running on my local host, and I also have Dapr running on my local host. So I'm just initiating this function app, which does the which is coming up. Okay. All right. So my function app is initiated with Dapr. Now I go here. I just initiate create new order call. Right. Sorry. I'm creating an order with the number 50. Okay. I'm then running it. Right. I go here and then the call will come to function app. Okay. Sorry. It's taking a bit of time for my function to come up. Oh, sorry. It's a demo fever. All right. Sorry, something went wrong. I think I'll quickly go to my cloud version. There is some problem with my machine with created in cloud. Can you see my screen? Oh God. All right. So I think what I have done was while we do the functions execution on the local setup, we can also do the function execution on the cloud. So I can create a function app and then in a container app environment, and then configure Dapr as an infrastructure as a code, and where I have a sample here. I will quickly show how the sample infrastructure as a code will look like. I have a code here which has enabled with the Dapr configuration true, and then the managed environment. Uh, uh, the actual code execution will take a bit of time, so that's the reason I have created my all these resources as a using bicep script before the demo itself. So I have these resources deployed as part of the quick start, where it will create container app environment and creates the function app along with the app insights for intercepting the traffic and monitoring the requests that comes to the function. So I quickly go to a postman, and I will create a new order from here, and we will see that how it will get executes on the So I will create an order with 51. This is the a function app that got created, which we have seen here. And then this is the Dapr invoke bind trigger which we are using. And the create new order is the actual API that we are initiating. And I'm passing the payload, which is order ID as 51, and it is sending a request and which will create this order. And if you see here, order ID 51 has been created. We can quickly check that, okay, using the retrieve order, it's a get call. I can run this retrieve order API to see that what was the latest order created is stored in the ready state store. If I go to my Azure resources here, we can see that Azure Redis cache, which I used as a state store, as I have shown in the diagram. And you can see that order 51 has been created. Then this is my app insights resource, which was created as part of the script. And if you see that there is a server request coming in, and this is the response time, you can see that the request inflow and outflow here. And then I go to logs, and then I see the same thing from here. If I just say traces and then run, it will show the traces. Yeah. So if you see here, this is the order ID 51. That was the one which we created just now. And we can monitor that, yeah, with the service invocation call has been happened, and it created this order. This is how this is that's yep. So
Final notes. But we did see in your demo, from invoking an Azure function with the application insights, saving the state to Redis, and creating a new order end to end. And we have a link at the bottom here in case anybody wants to check out this demo as well. You can then deploy it yourself to your own Azure Container Apps environments with Functions and Dapr. Cool. So thank you, Ramya and Radhika, for the overview and deeper dive into the Azure Functions extension for the Dapr extension for Azure Functions. Sorry. And any other notes before we get to the next section.
Yeah, thanks a lot, Tiago, and thanks for the opportunity as well. It was great to kind of walk into your show and talk about Dapr extension and the new uh, 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 areas of work that you're currently working on and that just got released. So I've dropped in the link to the bicep script that Radhika just demoed. So I encourage folks to kind of try it out. We also have GitHub repo for Azure Functions on ACA and the Dapr extension. So if there are any issues or you would like to make some feature asks or requests, so I'll drop the link here too. So yeah, look forward to all the feedback and your asks, and or if there are any issues, we're happy to support you.
Great, thank you. All right. So I'll take over now and talk us through some updates from last week, both from Ignite and also from .NET Conf. There's a link here, aka.ms/funkignite 2023. It'll take you to a blog post that has the full list of all the announcements from Ignite and also things that we have released this year in case you need to just do a quick refresher of everything that Azure Functions has been updating on this year. I picked out a few of the things that we announced that are more recent and happened last week, and let's go over those. So the first one is if you have a Mac that is on the Apple Silicon, now you can develop Azure Functions. This has been a long-standing issue that we've heard from customers. So now you can use the Azure Functions core tools, locally if you want to use the func commands to create a new function app and debug it locally. That'll be supported, as well as VS Code would work now on Macs that are on Apple Silicon. And we'll plan to keep expanding it to other devices that are on ARM as well. Here's another one that Ramya knows all about, and she wrote the blog post on this, so I'll add Ramya back to the stage, but it's the KEDA add-on to Kubernetes. So this isn't necessarily directly related to Azure Functions, but it's the Functions team and our engineering team that build and support this, and we are very happy that we are now have released in GA this add-on to Kubernetes that is supported for you to run, use KEDA for scaling your containers if you're on Kubernetes. And of course, running on those containers, you could have, bring your own Azure Functions if you would like, but you can have anything running on those containers, and they would be scaled by Kubernetes. And then because it's an add-on, we will make sure to release updates to it and keep it up to date for you. Any other notes, Ramya, on this one?
No, you covered it all perfectly. Yes, as Tiago mentioned, it's gonna, the add-on is enabled as part of your create AKS cluster experience, or if you've already created your AKS cluster, you could update your AKS cluster with the add-on, and so the latest and the greatest KEDA images would be available. So yeah, do try it out. And this is the most asked feature among the customers to kind of get it out in GA. So I hope you find this helpful and ready to kind of bring in your production workloads to the AKS cluster as well as functions using the KEDA add-on.
Great, thank you. And another one is we've been doing quite a lot of work to keep Azure Functions up to date with the latest versions of the languages that we support. And of course, Node is no different. So we've released in preview support for Node 20 now. And previously in the year, we also have Python 3.11, for example. So for all the languages with the latest versions, we are making sure that we keep the functions up to date with those languages. And on that note, we want to also announce that we announced last week at .NET Conf that we are supporting .NET 8. So .NET 8 came out this week, and Azure Functions already had support for it. And it works at the moment in the isolated worker model, which is where Azure Functions is going to investing quite a lot of work in. If you look at the original blog post that I mentioned earlier, that has all of the details, it also covers all of the great improvements that we've made to the isolated worker for .NET this year. So ASP.NET style support, updated to SDK bindings, so you can bind it to the actual SDK types in the .NET isolated. Even for Service Bus, a big request that we had for the .NET Worker was to be able to have peak lock and advanced messaging completion and other support there for Service Bus. So we we have added that to .NET Isolated now, so that it is on par with the support that we had before in the in-proc model. We've also done quite a lot of work on the upgrade experience with the Visual Studio extension to do a .NET upgrade on Azure Functions Apps. And also we have documented really well what steps you need to make to update your application as well to .NET 8. The in-proc will come as well, but at the moment we've released it in the isolated worker model only. But there's a link here to learn more about that as far as the roadmap goes. And then finally, we did have two folks from our Azure Functions team present a session at .NET Conf last week. So that link there will take you to the recording on YouTube as well. So you can check it out and go deeper into all the details about .NET support for Azure Functions overall as well. And the last announcement that I wanted to call out is Azure Functions Flex Consumption. So what we announced last week is an early access preview and a link for you to sign up or fill out the form to join the waitlist for it. But it's basically an evolution of the consumption plan where we are, and the Ramya called out before Azure Functions running on container apps, and if you have bring your own container, if you want to bring your own containers, if you want to run functions with other microservices that are already on your environment, that is the best hosting place for your functions there. But if you want to have a serverless option that is independent and is Azure native, you would have, this will be the best hosting option for Azure Functions. And it's called Flex Consumption. So the things that were implemented for Flex Consumption are very fast scaling and scaling out much further than you can now in any of our hosting plans. You will have some concurrency control where we will have a lot of good defaults that will already take care of most of the applications, but you can change how much concurrency you have per instance of your application, so that kind of helps the platform decide when to scale your app up and down. You'll be able to have choice of instance sizes. So for example, at the moment in the early access preview, it's 512 megabytes, 2 gigs, and 4 gigs are the 3 instance sizes that you can choose. And those are the sizes that will be used for your app to scale out and in. And then besides the flexibility of scale with both instance size, concurrency, and very fast and large scaling out, we are also happy to introduce VNet support or private networking support for a consumption model of Azure Functions, which means that you will get the same networking features that you have with the premium plan and app service plan, but on a serverless model, a fully serverless model. So you'll be able to have your function reach things that are secured inside your own virtual network, or vice versa, secure your function to be only called by things that are inside that virtual network. And finally, basically here, the last one is serverless, which means that those two things, scaling and private networking, but apply to a fully serverless model where you only pay for the instances that are used for your app and for those instances only while they have executions going on. There's quite a lot of other features that we plan for Flex Consumption. One is always ready instances as optional. That means if you need to set a minimum number of instances, say for example, if your app itself is introducing a lot of cold start to your application and you need to have a few instances always ready, then you will be able to set that number as well, just like you can now with premium functions, but this is optional on Flex Consumption. And then it's not no maximum, it's more like it will allow for longer function execution as well. So it will be much longer than the current consumption plan allows for a function execution to run for. It won't be without maximum, but it will be pretty long. So here's the link if you want to join the waitlist, aka.ms/flexconsumption/signup. And we plan to get people that sign up here onboarded to this early access preview environment around February. So if you sign up now, we'll know for sure that you want to get in, and we'll get you in as soon as we can. I have a quick demo here to show, just to showcase those two things, scaling and virtual networking. So let's say you have customer feedback and support cases coming in as a lot of feedback through HTTP from your online platform. And say if you just launched a big campaign, release a lot of new products, and you're getting a lot of feedback, or maybe the platform is not working as expected, and customers are just sending support cases in. We're ingesting all of that via HTTP into a Flex Consumption app, and then we want to send those support cases downstream via event hubs to be processed into a final database or a final system that will take care of those support cases, which is a pretty typical scenario that we've seen from customers. But the key thing here, besides the lots of support cases coming in, is that Flex Consumption is talking to event hubs here as the downstream system through a virtual network. So let's have a quick look at that. So I have here typical .NET isolated app. It takes in an HTTP request to process customer feedback, an HTTP post, and then I'm creating some AI embeddings from the HTTP post content, and then I'm outputting it to Event Hub's output. So basically, I'm using the regular Azure Functions output binding to send that data of the embeddings of the customer feedback to Event Hubs. So typical, the same as you would write now. And then I previously used the bicep template here to deploy my function to Flex Consumption app. So if we have a look here at what the function app looks like, you can see that now the SKU and the tier is Flex Consumption based. So here on my browser, I have the resource group that bicep template created, and I have my app here. So that's the Flex Consumption app that it defined. And if we go into application insights here that is associated with my function app, we can see through the live metrics that you couldn't connect to the application because it's basically scaled to 0. It's a serverless app, of course. So there's nothing for the live metrics to connect to. But let's change that. Let's kick off a couple of load tests. I have here the great Azure load testing service. And I'm going to kick off a run for it to send around 20,000 requests per second into my function app. And then just for fun, I'm also going to kick off a loader.io test as well to send about the same amount of load into my application. So while those two are kicking off, another thing I wanted to show you is the event hubs, the event hubs that is downstream from our Azure function. If we go into networking here, you'll see that public access is completely disabled. And we do have a private endpoint connection for that event hub. So only things that are inside that network, your virtual network, can connect to this event hub. Even trusted Microsoft services wouldn't be able to bypass this firewall. But how does the Azure function connect to it? Well, we have virtual network integration configured on the function app. So here I'm just going to list out the VNet integrations for my app, the same app that we saw before, FC Ignite 2023. And as you can see, there is a virtual network configuration integration into that same VNet and the app VNet for that VNet. So that means that it can actually reach the event hub. So let's have a look at how those load tests are going now. Okay, so we can see that the function app is scaled up. Let me zoom in here. to around 115 instances. I left it with the default of 16 HTTP concurrency per instance. So it basically took I think probably 18,000 requests per second that we have going on now, and it calculated, I need around 110 instances to be able to handle that because of that concurrency setting. And then the app, those instances are just reused for more and more HTTP connections. So this is a pretty fast, from 0 to 20,000 or 18,000 requests per second. And there will be another load test that will kick off soon here to take that up to, say, 40,000 requests per second if we want to. I also have another view here of a log from Application Insights that I want to show you, just to give you a better idea of that scaling to instances. So I'm going to run this. This is a previous load test that I ran last week. But as you can see from the chart, we were at 0 instances processing. So basically, you're not paying for the app. And then as soon as the first load test kicked off, it went up to around 103 instances handling that load. And when the second one, and then they're both sending HTTP requests to the app, it went quite quickly up to 176 to be able to keep up with that load. And then as the true load test, the first one went down, and then the second one went down, and your app is scaled back down to 0. Of course, the platform keeps those instances, for a while running, but you're not paying for them, and there's no need to process any more executions. So it's effectively scaled to 0 for you. All the while, it's sending events to event hubs in the backend, which through the virtual network. So hopefully this gives you a good understanding of what flex consumption will be able to offer you. It's basically a great improvement over our consumption plan that introduces virtual networking. One of the biggest pieces of feedback that we've had for customers is a consumption plan with VNet, but also for customers that need to have high scale and high throughput, or fast scaling, fast throughput, this will also take care of it for you. And with that, that's my demo, and just wanted to add Ramya back to the stage here. And we're pretty much done with the November live stream. I hope you enjoyed both.
Hey, Tiago.
Yeah.
Before you say bye, I want to call out. So we have a question from one of the guests here. So the question goes, hey, I guess only isolated or .NET isolated or Node.js v4 implementation model would work with flex consumption?
Yeah, that's a good question, Kai. For flex consumption, you are right. We are only planning the isolated hosting plan model. And that is the direction that Azure Functions is going. If you haven't noticed, we're going to that direction anyway with .NET with isolated model. And for the current preview, we are supporting .NET 6 isolated, and we'll, of course, .NET 8 isolated will be there too as we progress to public preview and GA. And then of course the other languages are already isolated, so those will be supported by default. In the preview, in the early access preview, we have specific versions of the languages that we support, but by the time we go public preview and GA, we would bring in all of the the recent supported versions of those languages as well. So I hope that answers that question.
Cool. I've also dropped the link to join the waitlist. So we've already started folks responding that they've signed up. So, yep.
Thank you. And this is probably the last one for the year. So happy holidays for everybody. And thank you for joining us. Or if you're watching the recording, thank you for watching the recording. And make sure to check out all the links that we shared on the slides as well. There's a ton more information there about each one of these announcements. So looking forward to hearing how you use our new features and also any feedback that you have. Thanks, everyone. And thank you, Ramya and Radhika, for joining us. We'll see you next year. Bye.
Bye.
Bye.